All right. So let's kind of do some problems where we combine our methods. Eventually, we're going to want to be able to factor any polynomial, and it could require using the GCF, the grouping, and then some more methods that we cover in the rest of the chapter. Here we just have GCF and grouping. So factor out the GCF, then factor by grouping. Okay. So I'm going to do one, and then I'll give you one to do also. So let's do 3x to the 5th plus 4x to the 4th minus 6x cubed minus 8x squared. All right. So start by getting your GCF out of there. So looks like, okay, no factor of 3 is going to divide 8 and vice versa. So no numbers for this one. Looks like we can get an x squared out though. So take an x squared out. What's left will be 3x cubed plus 4x squared minus 6x minus 8. All right. So now this is something, the x squared, make sure to keep it, but it's pretty much just along for the right at this point. Now we're going to use grouping on this thing with 4 terms. So we've got an x squared. All right, I will group together the 3x cubed plus the 4x squared. All right, and then keeping the negative with the 6, I'll have plus negative 6x minus 8. All right. Now, greatest common factor here. So nothing in common between 3 and 4, but we can get an x squared out. And then what will be left is a 3x plus 4. All right, and then here, we're trying to match 3x plus 4. It looks like if I divide by a negative 2, then I can get both things to be positive, and then I'll have a 3 as a coefficient. So take a negative 2 out. Minus 6x divided by negative 2 is positive 3x, and minus 8 divided by negative 2 is positive 4. We got them to match. Now we're ready to factor out the 3x plus 4 from these two terms in the parenthesis. And what will be left is the x squared and then the negative 2. And that's it, all factored. All right, so go ahead and give this one a shot. It's a little bit of a challenge problem. So let's take x squared y minus xy squared minus x squared yz plus xy squared z. Okay, so we'll go ahead and pause the video for just a moment. Try and work this out. When you're ready, hit play. All right, so first we need to find our GCF. So our z's, well, we don't have a z in these terms, so that won't be part of it. Okay, and then maybe look at what's the lowest power of x that we could get out. Looks like an x to the 1 is the best we can do there. Okay, and then also looking like a y to the 1 is the lowest power of y. So that our GCF is x times y. And if we go term by term and divide that out, so we'll cancel 1x, we get an x, just an x for that one, minus, okay, xy squared divided by xy, the x's cancel, we just have 1y, minus x squared yz, so we cancel an x and the y, so we get x, z, finally xy squared z, we'll cancel the x, we get 1y left, and the z. All right. So we've got the GCF out. Now we need to pair them up and make sure we take the negative sign in the second pair. All right. So what do the pairs have in common? What are their GCFs? Well, this one, there's no common factor except maybe a 1. I'll go ahead and write that because it's kind of useful later. Here, okay, we have a z and an x, or a z in both terms. And then we want to make this, so we'll be left with an x if we take the z out. And it's got a negative sign. We want to make it positive, so let's take a negative z. Okay, minus xz divided by negative z becomes positive x. And positive yz divided by negative z becomes a negative y. Perfect, we got them to match. Now all we need to do is we still keep our GCF. Here we're going to factor out the x minus y. And then what's left is a 1 minus z. And that's it.